So, welcome students. In the last class, we talked about the classification of polymers. In the today's video, we are going to talk about the types of the polymerization. In the last class, we talked about what is the polymers, what is polymerization, how many types of polymers are there. So, different examples for all. Okay, so today we are going to talk about the polymerization. As I said earlier, what is a polymerization? What is a polymerization? The process of forming a polymer. So during the polymer we have different types of classifications. So the polymerization is classified mainly as two types, that is the addition polymerization and the condensation polymerization. Addition polymerization and the condensation polymerization. So what is the addition polymerization? So addition polymerization is nothing but we're adding some different types of monomers, just like we are linking the chains like that. So we are adding some monomers and therefore we are not eliminating any smaller molecules. That we call it as addition polymerization. So this is again further classified as the following types. Depending upon the mechanism, okay, the process by which this addition is following. So depending upon the mechanism, the addition polymerization is classified as mainly free radical polymerization, ionic polymerization, coordination polymerization. Of course, co-polymerization is somewhat different. So here, generally it takes some different types of monomers and we are adding it. So generally this co-polymerization was observed in elastomers. Okay, so co-polymerization in the sense, these are the unsaturated monomers where we are adding and the monomers are different. So we'll discuss this co-polymerization when you are talking about the elastomers. So now, depending upon the mechanism, today's class will talk about these two especially. Depending upon the mechanism, this addition polymerization is divided as free radical polymerization, ionic polymerization and coordination polymerization. Apart from that, addition polymerization is also called as, classified as condensation polymerization also. Okay, now next, what is this addition polymerization? So as I said, addition polymerization in the sense we are adding something, okay? We are adding something, okay? So here I am taking two monomers. So let us consider I am taking two monomers, okay? So in order to undergo the addition polymerization, the monomers should always be identical in nature and it should definitely contain unsaturation. So without this, we can't go for addition polymerization. Okay, so let us take an example, that is polyethylene. Polyethylene. So CH2 double bond CH2. So CH2 double bond CH2. So say I take two monomers, CH2 double bond CH2. So whenever I'm adding this, so how can I add these two monomers? These two are identical and these two are having unsaturation, right? So how can I add these two? So how can I add means, you all know a double bond contains a sigma bond and a pi bond, and a sigma bond is a strong bond and a pi bond is a weak bond. So in order to add these two monomers, I have to break this pi bonds, okay? I have to, in this fission, or we have to cut the monomers. So here I'm cutting this pi bond and therefore we are getting CH2 single bond CH2. As I said, in the functionality, the number of the reaction sites present on the monomer, that is called as functionality. So I have taken a bifunctional monomer, so therefore the next monomer can add either this side or this side. So as in the last classes we discussed, right? So here there is a chance for adding this side or this side. So anywhere we can write. So I am simply adding at any side. So I have taken two monomers. Okay, so I'm taking two monomers. So CH2. So CH2 double bond CH2. So I'm adding with another monomer. So CH2 double bond CH2. I'm getting CH2 according the bifunctional. You can add on any side. So CH2 double bond CH2, right? So then this is the monomers, two identical monomers, and we have gotten this polymer, right? So how many monomers you can add? So I can add from 2 to infinity. How many? Depending upon our requirement, we can add many number of monomers. And during this addition, I am not getting any byproduct, right? In general, chemistry, they say, when I'm adding some A plus B, I get some C plus D, right? So this may be a smaller molecule like H2O, HCl, etc. So this does not happen in the addition polymerization. So what is the addition polymerization means? Adding of two or more identical monomers, without any elimination of smaller molecules, then it is called as addition polymerization. So now let us write the definition for this. So what is the addition polymerization? So what is addition polymerization? Two or more identical monomers, combine to form a polymer. Two or more combine to form a monomer. So what is the basic requirement? It should definitely contain unsaturation, right? So double or triple bond. So two or more identical monomers combine to form a polymer without the elimination of smaller molecules, like H2O, HCl, etc. So that is called as a addition polymerization. Okay, clear? So I am adding two identical monomers to get a polymer. So when we are taking n molecules of A and n molecules of A, what happens? You get A, and so on, right? So can I write this as A to the power singly like this? So I have written a single bond means I can add a monomer on this side, okay? On this side or this side. So these are the reaction sides. So this is the addition polymerization. Okay, now clear? Two or more identical monomers combine to form a smaller molecule without the elimination of smaller molecule. Without the elimination of smaller molecules, it is called as addition polymerization. Okay, clear? Now let us discuss about the characteristics of addition polymerization. How can we undergo this? So what are the characteristics of addition polymerization? What are the important features or the salient features of addition polymerization? So the first one, as I said, the monomers should always be identical. This is the first clause for to undergo addition polymerization. Next, second one, we are linking the monomers, right? Sir, we are linking the monomers. We are adding one monomer with the another monomer. Hence, and can we say like we are linking the monomers? We can say to when they are linked with one another to form a chain, right? Therefore, the addition polymerization is also called as chain polymerization. Okay, so it is also called as chain polymerization. So addition polymerization can all be called as chain because we are linking the identical monomers to form a long chain. Okay, next, third one. There is no elimination of smaller molecules. So we don't have any HCl, H2O, etc. as byproducts. Next, fourth one. Okay, so during this, in order to undergo this addition polymerization, we definitely need an initiator. Okay, so without the initiator, the addition polymerization cannot be started. So here we require some initiators like peroxides, benzoyl peroxide, okay, or H2O2, hydrogen peroxide, sunlight, etc. So these are some of the HNU. Okay, so these are some of the initiators required for the addition polymerization. Okay, next. once the addition polymerization is start, it is always rapid and continuous. So it takes place, so just like linking the monomers, right? So it takes place rapidly, and it is a fast process, means slow, it doesn't take much time. Next, seventh one. In order, when we are combining a single bond, so we are changing the pi bond into a sigma bond, right? So here, let us see here, I have taken some double bond. So CH double bond CH, added with CH double bond CH, right? I got HC, HCH like this, right? So if you can observe, I broke the pi bond and changed this into a sigma bond, right? So therefore, it is a exothermic reaction. So it is exothermic in nature. So it is exothermic in nature. Next, what is the next one? So I have taken some 4 molecules of A and formed a polymer. I said, man, what is the gram molecular weight of the polymer? So you say that always the formed polymer, the gram molecular weight of the polymer, the okay, so is always equal to the algebraic sum of the weights of the molecular weights of the monomers. So we have taken 4 monomers. So what is the gram molecular weight? 4. So for each molecular weight is having 5. So 4 into 5, 20 is the polymer. So the algebraic sum or the integral multiple, okay, integral multiple of the molecular weights of the monomers involved in it. Okay, so these are the some of the characteristics. Okay, next. Then what are the other salient features? So during the formation of this addition polymerization, okay, so during the formation of the addition polymerization, so it follows some mechanisms. The mechanism follows 3 steps. First one is the chain initiation. What is the second one? The second one is the chain propagation. What is the third one? Third one is the chain termination. So these are the 3 steps involved in the formation of a polymer. Okay, Nan? So these are the different characteristics. So these are the different characteristics of the addition polymerization. What is the first one? I have written the monomer should be identical in nature. So the monomers is linking the monomers. Therefore, we call it as chain polymerization. Here, no elimination of smaller molecules takes place. Here, it takes place in the presence of some peroxides. Okay, so it is a rapid and continuous, and the gram molecular weight is always the algebraic sum of the monomers involved in it. So these are the characteristics of the addition polymerization. Now we will discuss the mechanism of each polymerizations one by one. So now let us go for the addition polymerization. Okay, so addition polymerization follows 3 mechanisms. First one, free radical polymerization. The next one is the ionic polymerization. So these are carried by the reaction intermediates. So in intermediate, in the lower classes, they say we have 3 reaction intermediates. So the reaction wholly follows through those intermediates. What are they? The first one is the free radical reaction intermediate. The second one is the carbonium ion. Okay. The third one is a carbanion. So if the C is having a radical, then we call it as carbon free radical. The C is exhibiting plus charge, we call it as carbonium ion. The C is exhibiting minus charge, then it is called as carbanion. So if the reaction is followed by these 3 intermediates, then we call it as addition polymerization. Okay, now let us talk about this free radical addition polymerization. What is this free radical addition polymerization? Okay, so free radical addition polymerization is the sense if the addition polymerization is carried out, okay, if the addition polymerization is carried out by a carbon free radical, free radical. Then it is called as free radical addition polymerization. Okay, so it is of the fall, as I said, it follows three mechanisms: chain initiation, chain propagation, and chain termination. And for any addition polymerization, we need an initiator. So what are the initiators? I said already, that is benzoyl peroxide, benzoyl peroxide, or it may be hydrogen peroxide, hydrogen peroxide. So I have taken both. So if benzoyl peroxide is taken as the initiator, so what is the chain propagation step? The chain propagation step is the what is the chain initiation step? So what is the chain initiation means? In this chain initiation, we create the carbon free radical. Okay, so whatever the reaction intermediate we are taking, so if we are taking free radical, so in order to generate this C dot, so that is the chain initiation. Or if we are going for anionic, so we have to create C minus. If we are going for cationic, we have to generate C plus. Okay, so in this step, the initiator reacts with the monomer, whatever you are taking. Okay, or that monomer, initiator reacts with the monomer and creates the carbon free radical on the monomer. That is the chain initiation. So I have taken the two examples. First one is the benzoyl peroxide. Okay, so this is the benzoyl peroxide. So if benzoyl peroxide is taken as the initiator, what happens? It quickly changes into benzoyl radicals, and it is very unstable, and it is changes into C6H5 radical and CO2. This C6H5 radical is responsible for the formation of the carbon free radical. Okay, if we take this hydrogen peroxide, so what happens? So this also cleaves into HO radical, and this HO radical reacts with the monomer. So if I take an HO radical, so CH2 double bond CHX, what happens? So this is broken and it creates HO CH2 CHX radical. So here in the place of C6H5 HO came. So this all takes place in the homolytic fission. Keep in mind, free radical addition polymerization takes place in the homolytic fission of the monomer. Okay, so here I have got the carbon free radical. This is the chain initiation. I repeat, so benzoyl initiator first changes into a radical, thus is reacted with the monomer what we are taking. That monomer is, in this monomer, the pi bond is broken and the initiator creates the carbon free radical. So this is the chain initiation step. Clear? Next, what is a chain propagation? So in the chain propagation, so whatever the monomer, that carbon free radical formed in the first step, so this is the free radical, right? So whatever this carbon free radical formed in the first step, initiate the another monomer. So I have taken another type monomer. What happens? Similarly, this homolytic fission takes place, and you get there is a chance to add this side because it is a substituent here. So therefore, you get a long chain. So this free radical is added to the monomer, and again another carbon free radical is generated. So if we take n type of monomers, so during the formation of polymer, we can take n number of monomers. Okay, so required depending upon our requirement, we can add any number of monomers. So that's why I have written n. So whenever I have taken n monomers, what happens? This small part is getting repeated, right? So C6H5CH2 plus CH molecule. So it is changing, or it is at every step, this carbon free radical is doing the homolytic fission. So at every step, you get this part is a repeating part. Therefore, I have kept this part as n. Because how many monomers you can add? So this part is the repeating step in the polymerization. Therefore, I have kept the n here. So this is called as a living polymer. Why I said living polymer means still there is a chance of adding one more monomer for this. Okay, or else you have to stop it. Okay, so how many number of monomers the required you have to add, and still there is a chance of adding one more monomer, that is called as the living polymer. So formation of the living polymer is nothing but the chain propagation. Okay, next, chain termination means I want to stop the polymerization. So, for example, I want to add 500. So already those are completed. So I want to stop it. So I want to stop. So I want to terminate means I want to remove this C dot on the polymer. See, if there is a free radical, so there is a chance of one more adding for this. So I want to remove this one. So that's why I'm going for chain termination. So chain termination can be done by two methods. The first one is the coupling and the second one is the disproportionation. Coupling and disproportionation. For that, I have taken the living polymer in the back step. So this is the living polymer, right? So I have taken the living polymer here. So this living polymer is joined with another living polymer, and just I have combined the ends of the living polymers, and thus I getting the dead polymer. So this is the first model, that is the coupling termination. Just couple or adding or joining, okay, the free radical ends and making a bond and removing that free radical on the carbon chain, that is called as the coupling reaction. Okay, next, the other one. We can also remove this free radical. We can also remove this free radical in the other model, that is the disproportionation. We can also simply say this as proton transfer also. For that, I have taken two living polymers. So in this step, we got the living polymer, right? Like this type of living polymer, I have taken two. So this is one living polymer and the other one is the other polymer. So what happened? So here I have got a CH2, right? So can I write this CH2 as CH single bond H? Yes. So I have written this CH2 as CH single bond H, and this proton is traveled to the other polymer. So such that whenever this proton is transferred, you get a positive charge here, and this free radical is getting combined and getting an unsaturated dead polymer. Unsaturated dead polymer. So when this proton is transferred to the second step, second polymer, what happens? This proton is changed into CH2X. So can we say this as saturated polymer? So this is saturated dead polymer. So through the disproportionation, I get two types of polymers. One is the unsaturated polymer. The second one is the saturated dead polymer. So this is the mechanism of the free radical addition polymerization. Okay. So I repeat. So we have chain initiation. So you get the free radical here, and you get the free radical on the monomer. This is the first step. The second one is I am getting the living polymer. The third step is I have taken the living polymers and I am changing the living polymers into dead polymers. That is the chain termination. So chain termination can be done by either coupling or proton transfer. Clear? So this is the free radical addition polymerization. Okay, next. The second polymerization is the ionic polymerization. So ionic polymerization is again classified into two types. Okay, the first one is a cationic addition polymerization. Cationic addition polymerization means I have to get the carbonium ion, right? So carbonium ion is getted on the monomer only by taking Lewis acids with water combination. Here Lewis acid acts as a catalyst and H2O acts as a co-catalyst. When we combine these two, you get a counter ion. This is called as counter ion. So through the generation of this counter ion, I can get the positive charge on the carbon, because it is not at all easy to get C+. Okay, so here it is takes place to the electrophile. Okay, so the process always takes place through a plus charge, hence it is called as cationic. So the counter ion, in the counter ion, the story runs around the H plus ion. Okay, and also the next propagation and the termination also H plus, that C plus plays a key role. Therefore, we call it as cationic addition polymerization. Okay, right. So for that, I have taken Lewis acid plus H2O, and this forms a counter ion. So when this counter ion is reacted with the monomer, okay, so here it is an a monomer, some X may be CH3, whatever it may be. Okay, so you can take different types of X combinations here. So when I polarized, here I have taken heterolytic fission, not homolytic fission, whereas in free radical you get homolytic fission. Here it is heterolytic fission. So heterolytic fission takes place and we get a C plus, and this counter ion is adding, it is in distance between the C plus, there is no bond between this. So this C plus is obtained, that H plus is transferred here, sorry, the H plus, sorry, the H plus is transferred here, therefore you get CH3, and this C plus charge is attracted with the minus, that is the counter ion. So this is the chain propagation, sorry, chain initiation. After that, this counter ion reacts with the n number of monomers. Okay, you can take n number of monomers, and these monomers react with one another and forms a long chain. Okay, so here also I am getting a living polymer. Here also I am getting a living polymer. So this is the step 2, chain propagation. Okay, so here also I am taking a counter ion. I repeat, so cationic addition polymerization takes place through the formation of the counter ion. So through this the electrophile is generated. So this electrophile helps to form the C plus on the monomer. So this is the carbonium ion. So this is the carbonium ion. So the formation of carbonium ion is the chain initiation. After this chain initiation, chain propagation takes place, means this carbonium ion reacts with n number of monomers to form a living polymer. That is the carbonium ion long number of, how many number of monomers you want, you can add. So this is the living polymer. This is the chain propagation step. Okay, chain termination. So chain termination takes place by 2 methods. So there are 2 different methods. First one is a proton transfer. So proton transfer means from the living polymer a proton is rearranged, and this is giving some unsaturated polymers, and that whatever this counter ion is there, it gets outside. So this is the first step. This is one model. So you are getting unsaturated dead polymer, and this is a very unstable. It quickly changes into Lewis acid. Okay, what is the chain termination? We get Lewis acid because this is very unstable. Okay, right. Now we are focusing on this. So we have taken the living polymer. So in this living polymer, the proton is transferred to the next carbon or rearranged, and it is giving unsaturated dead polymer. That is the first step for the proton transfer method. We can also next, that the second one, that is the disproportionation. Disproportionation, here this is also another model. So in that, what happens, this OH, this takes place in the presence of some base. Okay, we are adding with this. So during the base, what happens, this base is added to the monomer, and this BF3 is went out. Okay, so this is the second model. So this counter ion is getting cleaved, and due to the this is also rearrangement process. This OH is added to the living polymer, and that C plus is eradicated, and you get Lewis acid as a byproduct. So this is also another model. Okay, the first model is we are getting unsaturated polymer. The second model is I am getting a saturated polymer. So this is the cationic addition polymerization. Okay, next, anionic addition polymerization. Anionic addition polymerization takes place through organometallic compounds. So organometallic compounds means it is a combination of an alkyl group, we can say, or anything, C2H5, CH3, whatever it may be. Okay, so this organometallic compounds cleaves into Na plus and R minus. This is cleaving this monomer and I'm getting C minus. So I am getting the carbanion on the carbon chain. So this is anionic chain initiation model. What is the chain propagation? I have taken this. Okay, carbanion, and I have taken n molecules of CH2. I have taken n molecules of the monomer. I am getting the living polymer. So that is the second step. What is the living polymer? R CH2 CHX CH2 CHX n times CH2 CHX minus charge. Okay, so this is the chain propagation process. What is the chain termination? So chain termination, so I am writing directly, students. Okay, so I am taking this chain. This is the living polymer, right? So I am taking this living polymer and I am treating this with an H plus ion. Okay, some acid. So CH2, CHX, CH2, CHX, CH2, CHX minus charge. Sorry. R CH2 CHX CH2 CHX n times, so CH2, so CHX minus charge plus H plus. Okay, so when I am adding this H plus, what happens? Simply it is getting here and just you get the product as CH2 CH2X. Okay, that's it. So that is the chain termination process. So what is the product? So what is the product? So R CH2 R CH2 CHX CH2 CHX n times, so CH2 CH2 X. So this is the chain termination process. Okay, so in this class we talked about the different types of polymerizations. Okay, so what is the polymerization? How many types of polymerizations are there? So anionic, free radical, ionic, coordination and copolymerization. We talked about the definition of the addition polymerization. Okay, we talked without the elimination of smaller molecules in the presence of initiator, that is called as addition. We talked about the characteristics of addition polymerization. Okay, so how many types of characteristics or the salient features of addition are there? Then we talked about the mechanism of the free radical and cationic addition and anionic addition polymerization. So in the free radical, we created the carbon free radical. Next, chain propagation and chain termination. Next, we went for ionic polymerization, cationic and anionic addition polymerization. Okay, so in the next class, we'll talk about the different types of other types of polymerization, that is condensation polymerization, and we'll talk about the next topic, that is the plastics. Okay, thank you, students.